in lines of fit. So this is tying into what we did yesterday, reviewing how to write equations of lines. So now looking at one instance where equations of lines would be used to make predictions for things. So this first part is mainly just vocabulary. So it says at the top, data with two variables is bivariate data. And then a set of bivariate data graphed as ordered pairs in a coordinate plane is a scatter plot or dot plot. If you're not familiar with correlation, a scatter plot shows a positive or negative correlation, or maybe there's no correlation between the two variables. And a correlation would be, is there a linear relationship, in this case, between the variables? Correlation can also be strong or weak. So in a strong correlation, the points of the scatter plot are closer to the graph of a line. The points are closer together. They more closely make a line. If the correlation is weak, the points are more spread out. So if you were to draw a line of fit, they're farther away from the line, but they still kind of fall in a linear pattern. So it does give examples, first of all, of a positive correlation. So if you were to draw a line and that has a positive slope, it's a positive correlation. A negative correlation would have a line of fit that has a negative slope. You can see no correlation as if it literally just looks like your typical scatter plot is just a scattering of points. There's no line that seems to be formed. And then they just put the strong with the positive and the weak with the negative for these examples. You could see each. So strong, notice these points, they don't exactly all make a line, but they're closer to that line than if you compare it to this one. They're more spread out versus where the line is drawn. So that would be more of a weak correlation compared to this one. And when you make a scatter plot and then you find a line that closely approximates a set of data, you're finding the line of fit. You can use, which we'll look at this actually after your quiz, you can use graphing software, so whether it's on a computer or a graphing calculator, to get a best fit line or a regression line. So that is, as the name entails, it's the best line or linear function that would predict your data. So in this, an equation of a line is a prediction equation because it's then used to predict one of the variables given the other variable. So a value that you're not actually given in your data set, you can use that equation to predict the value of that. And this is just going through how to find a line of fit. So we would do that the same as yesterday. You would select 2 points that appear to represent the data well or represent your line well. And that's a matter of personal judgment. So your line and prediction equation may differ from those of others. So this is a case where on your assignment, on your quiz, on your test, you could have a different answer than what I have and still be correct. You could have a different answer than what I have and be wrong. So I'll show you what would be what I would consider wrong. But there are multiple answers for these. So I'll remind you of that tomorrow as well when you're correcting the assignment, if you do it, that your answers are probably not going to be the exact same answers I have, because whichever 2 points you choose, you may not choose the same 2 points I'm choosing to make your line. So if we look at the example that's on here, it shows the percent of U.S. households with internet access for these 5 years. And the first part says, make a scatter plot and a line of fit and describe the correlation. Let X be the number of years since 1995. So if a problem says something like this, that means we are not going to use the years as the X values. We need to come up with what the X values are. So if X is the number of years since 1995, in the year 1997, what will X be? 2. It's been 2 years. In 2000, X will be 5. It's been 5 years. In 2001, X will be 6. 2003, X would be 8. And then 2007, X would be 12. And you could always assign X values as well if you kind of had a starting point, like if you called the first one in a day set, if the numbers are very, very large and you wanted to use like 0 through 10 or something like that, you could assign a number to whatever your independent variable is. So then you will see graphs that are blank just because you can make your own scales for these. Obviously, if I had just given you a regular coordinate plane that's 10 by 10, then, or actually it'd be 20 by 20, not everything is going to fit, so you're going to have to change the scale, and you're really just working in that first quadrant with positive x and y values. So I'm just going to draw in the axes here. And I am going to label the x-axis. These are years since 1995. So in general, if you're making a graph, you should label your axes. And then the y values are percents, and it's percent with internet access. I'll just put percent of households here, just to show what it's measuring. And I did, this grid is 10 by 10. So I need to be able to fit the x values to, or 2 is the smallest, 12 is the largest. So if I just count by ones on my x-axis, I'm not going to fit the 12. So I would need to at least count by 2s. So I'm going to label the x-axis. And you don't have to have your x and your y scales the same, because obviously if I count the y-axis by 2s, not everything is going to fit. So if I have 10 spaces here, my lowest y value is 18, and my highest is 61.7. What could I scale my y-axis by? Could scale it by 10s. Yeah, because 5s would not. That would only go up to 50. Okay, and then you would just plot the points you're given in the table. So I have 218, 5, 41.5, 6 is at 50.4, 8 is at 54.7, and 12 is at 61.7. Okay, and then as you're looking at that, so we made the scatter plot. You only make a line of fit if you determine that there is a correlation. And when it says describe the correlation, you're describing it as positive or negative, and then strong or weak. The strong or weak might come in when you actually draw your line to see how closely your points all fit to your line, if you decide to draw a line. So would you say that there is a correlation, that they appear to fall in a linear pattern? Yes, okay. So there is a correlation. Would it be positive or negative? Positive. So if you take your rulers and draw in your line of fit. Now, when you're drawing your line of fit, you want it to be approximately in the middle of your data. So, for example, you want to have about the same number of points above and below your line. So you want it to be as close to the middle as you can get it. It does not have to go through any of the points that you drew. It doesn't have to. It certainly can, and it might and probably will, but it does not have to. So if I were to try to get this in the middle of my data, and you want to make sure too that it shows like the pattern of your data. Let's see how I want to draw this. I'll draw mine like that. Yours might not look the exact same as mine. So something that would be wrong is drawing it like, I'll try to line up my rule. Like if I drew it like this, so you want to actually make sure that you're following from the first point you drew to the last, you're following the trend, that your line seems to fit well in the middle. You can always ask too when you're doing the practice if your line of fit looks okay. But if it's clearly like not following that trend or going the opposite direction, it should be something's off. So I'm going to say, I made my scatter plot, drew my line of fit, describe the correlation. So I'll say the correlation is positive. And then would you say that it's strong or weak? I heard a weak. Everybody agree? Anybody think strong? Change your mind to strong? Okay. Let's change your mind to strong. Any other opinions? Okay. I would say these points are pretty close to that line. There's not many points to go off, so I would call this strong. So the correlation is positive and strong. We don't have any points that are very, very far away from our line. That's all you have to do for describing the correlation. And that means we're done with part A. Okay, so then in part B, in this part, this is where your answers, here, your scatter plot should look roughly the same depending on how you scaled it. You could scale it differently from somebody else. Your line of fit might look slightly different. And then part B, use two ordered pairs to write a prediction equation. This is where you will most likely have different answers from other people. You want to make sure that you're choosing 2 points that are actually on the line that you drew. So make a note, choose 2 points on your line. They do not have to be any of these points. So this is what I see happen on quizzes with this, is I'll have students choose like this point down here. My line is not even touching that point, so I should not be using that point to write the equation of my line. My line does not go through it. My line, the way I drew it, and I kind of did this on purpose, it is in the middle, but the way I drew it doesn't really go through any of these. It's kind of close to touching these points, but I wouldn't consider it actually going through them. So I would look at this and say, the way I drew my line, and you can base this off of how you drew yours, my line appears to go through like this point right here, which would be 1270. Okay, it's not in my table, but the way I drew my line is going through it. I try to pick easier ones, and you do want to pick points that are maybe farther away from each other. So maybe I'll say, and it is a rough estimate too, I realize that, but I might pick this one because that appears to go through 4 and then 35 just about based on how I drew it. Okay, so I didn't pick any points from my table. Certainly if my line went through one of those points on my scatter plot, I would use those first, but you don't have to. So I kind of drew mine this way on purpose to show you that you don't have to use those points, and you shouldn't if your line doesn't go through them. So now I have to write the equation of my line through these 2 points, and we did this yesterday. So I need to find my slope, and then I need to use one of the methods to either find B or use the point slope form to get my equation into slope intercept form. So if I find my slope first, and if you're using different points, you can kind of compare because you can use points that are actually on your line. My change in Y would be 70 minus 35 over my change in X is 12 minus 4. So I would have 35 over 8. And this is where, with these equations, it is okay to write your slope as a decimal. I would still try to keep it as a fraction if it's a repeating decimal though. So maybe I should just keep mine, 35 over 8. I do have a terminating decimal, 4.375. So if I used that, it would be okay to express it that way. Just because these, especially when you have, if you were using any of these points and you have decimals, having a decimal in a fraction isn't simplified anyway. So it is okay to divide and have a decimal here. And then if I choose one of my points, I'll just use the 435. With my slope, I'm going to use the point slope form, the y minus y sub 1 equals m times the quantity x minus x sub 1 to write my equation. So I would have y minus, my y coordinate is 35 that I'm using. And then I have 4.375 as my slope times x minus, my x coordinate is 4. Move this up, and then I would solve this for y, distribute my slope. So 4.375x minus, this times 4 is 17.5. And then I would add my 35. So my equation is y equals 4.375x. Oh yeah, that's exactly half. So plus 17.5. So on your assignment, you should kind of label which points you're using, but on your quiz, just so you know, the quiz you take Thursday, I ask you for this part which points you're using, and then the way I grade that question is, did you get your correct equation based on the points that you chose? Because your equation, unless you chose the exact same 2 points I did, your equation is going to be different. Okay, and then for C, you're now using this equation to predict the percent of households with internet access in 2020. So if the year is 2020, what is X? 15. Actually, 25, yes, because 1995. So 25. So careful if you are using different X values. I'm not actually substituting in 2020, so I would substitute this into my equation. So y equals 3.75, or no, that's not my slope, 4.375 times 25 plus 17.5. Okay, and I get my y value to be 126.875, and that is a percent. So yes, everyone. Okay, that is what my prediction equation told me. D then asks, because this is math and science, when you're actually using data to make predictions, then you have to decide, is that reasonable? So it says, how accurate does your prediction appear to be? So if you were to think about this in the year 2020, so next year, do you think every single household in the United States will have internet access? I heard a yes. I see some no's. Do you think everyone now has internet access? No. So there are places that probably don't, even though that the percent that actually will in 2020 is probably pretty high, like closer to 100. To say that every single household will have it is probably unreasonable. So I might just explain that. I'll say it's unreasonable to think every household will have internet access, but I'll say the percent is probably close to 100%. And then you also have to look at how far out. So the last data point we had in our table was from 2007, and we're trying to predict 13 years later. So you have to kind of look at that. The farther out your prediction occurs, that's called extrapolation when you're predicting something that's outside of your data set. The farther out, the less accurate that tends to be versus if we were predicting like if we were predicting how many had it in 2005, because that would be in between these years, that would be interpolation, then that would be a more accurate prediction because it's inside of our data. But the farther out you go, the more iffy it becomes. But it is just a prediction. Okay, questions on that? Okay. So that's what we are doing with scatter